Good day to you, my viewers from any part of the world. You are privileged to be seeing this video at this hour. Thank you very much for tuning in to this channel. And my name is Mr. Femi, and I want to walk you through basic map reading and interpretation, an aspect of practical geography. I will be teaching today from my book I wrote many years ago, titled Compendium Practical Geography, a simplified approach to map reading and interpretation. It's actually for secondary school, high school students that want to write IGSC, that want to write WAEC, NECO, or any certificate exam for secondary school or high school student. And it's also for first year geography students that want to do exceptionally well in their geography exam, especially when it has to do with aspect of practical geography, map reading, and interpretation. So thank you for tuning in once again, and thank you for joining the class. So before now, I've been able to teach on basic essentials of a map. We have been able to look at distance, direction, and bearing. We've been able to look at scales of a map. We've been able to look at scale conversion. We've been able to look also at measurement of distance as well as measurement of area of a map. So in the last video, we were able to look at map reduction. So today, without wasting time, I'm going to be walking you through how to carry out map enlargement. So permit me to also walk you through conventional signs that we use in map reading. So when we talk about map enlargement, basically what we do is to reproduce a map in a very big form, in a bigger form actually. So if a student or a candidate is required to enlarge a map with a given scale, how will the student or candidate go about it? So there are 6 basic steps to map enlargement. So the first step is to use the formula old scale all over new scale, and if the answer is there is a whole number, then you are to enlarge it. I said in the last video that there is a formula, and the formula is old scale over new scale. If you get a fraction, that means you are to reduce the map. But if you use the formula old scale over new scale and you get a whole number, then it therefore means that you are to enlarge the map. So basically, when you look at the map and the scale of that map is a way lower, let me say bigger than the new scale you are given. If the scale you are given is lower than the scale already in the map, originally in the map, it means you have to enlarge. Let me explain this concept, because many students, many candidates, they get to exam hall and they are unable to decipher what the examiner actually wants them to do. Now, I said in the last time that the smaller the map, the bigger the scale. The smaller the scale, the bigger the map. So if you want a big map, then if you want to enlarge your map, then you will be given a small scale. So if your old scale is bigger, let's say 1 to 250,000, and then you are given a new scale, and in that new scale, the scale is 1 to 150,000 or 1 to 50,000, automatically you know you are going to enlarge the map, because 250,000 over 50,000, that will give you 5. So that is a whole number. But if you are given otherwise, let's say original scale in the map you are presented with is let's say 50,000, and you are given a new scale to reproduce another map, and that scale is to a scale of 250,000. So if you put your old scale 50,000 over the new scale 250,000, that's going to give you 1 over 5. That's automatically a reduction. You have to reduce the map. Okay, so let's go with this step. The first step is to use the formula like I said, then use a ruler to measure the length and breadth of the map and multiply it with your answer, which is the whole number you get in the step 1. Then you divide the original map into grids of equal size like we do in the map reduction. Then you draw the outline of the new map using the new length and breadth that you have just multiplied here in the second step with the whole number you get from the formula. So then the next thing you do is to, after the step 5 above, you can now transfer all the required features from the old map into the new map, square for square, as they appear in the original map. So I put a caveat here that note, when a new scale is not given, as with the step above, that means you may be required directly to enlarge the map times 2 or 2 times of its original size, or 4 times or thrice of its original size. So you are going to be it's going to be explicitly stated in the question that you are given so map, please reproduce the map 4 times its original size. But if you are not told that, then you will be given new scale. Then you now use the formula to convert the new scale or old scale over new scale to determine if it's a fraction or a whole number. All right, so let's move forward. All right, so steps to take when new scale is not given. Measure the length and breadth of the old original map and multiply them individually by the whole number, that is the number of times you are required to enlarge the map. Then secondly, you multiply the scale of the original map by the number of times you are required to enlarge the map. For instance, if the old scale is 1 to 150,000 and you are required to enlarge the map times 2 of its original size, what you will do, this is the scale you are given, then you will say 1 over 150,000 times 2, and that will give you 1 to 75,000. Automatically you can see now that 150,000 is bigger than 1 to 75,000. So invariably, if you use the formula now in quotes, if you use the formula and say 150,000 divided by 75,000, you are going to get 2. The same way it suggests to you that you are to enlarge the map by twice its original size. So new scale becomes this. So note, always convert statement scale to linear scale or representative fraction before you do the calculation to avoid error. Look, if you are given in the new map, in the old map, in the original map, if you are given a scale and they write there 1 centimeter represents 150,000. If you are given like that in a statement form, please don't forget to convert it and write it in a representative fraction, which means that you are to write that 1 centimeter represent 150,000. You will write it as 1 ratio 150,000. So which is what this place is explaining. So the original map, you divide the original map into grids of equal squares or an interval. Then you draw the outline of the new map using the new length and new breadth. Then divide the outline into grids of equal square, the same number of total grids with the old number, with the old map. Then after that, you transfer the features square for square accordingly as we see. Now, do you understand what we are talking about now? Let me test your understanding. Let me know if you really understand. Please, I want you to mention the formula for map reduction and enlargement. If you are to know whether you are to enlarge or to reduce a map, what is the formula? I want you to answer that. Then number 2, state 2 reasons for map reduction and enlargement. State 2 reasons for map reduction and enlargement. Send your answer to practicalgeographylectures@gmail.com. practicalgeographylectures@gmail.com. So let's look at conventional signs, because this is very important. Conventional signs, they are signs that are frequently conventionally used in a map. And at the end of this session, I am very confident that you will be able to identify some major conventional signs that are often used in the map. So now there are 4 basic facts about conventional signs, and these are the facts that are presented here. So the first one is that conventional signs represent both natural and human features that are found on a map. Conventional signs are the languages of the map. Without conventional signs, you cannot read a map. Don't forget, we are doing map reading and interpretation. Without conventional signs, you cannot read a map, because the language we use to read a map is the conventional signs. So you study map through its conventional signs. So number 3 fact about conventional signs is that they are usually shown at the bottom of all maps. Usually they are shown at the bottom of all maps. Then number 4 is that conventional signs enable map reader to understand and interpret the map. Like I said, without conventional signs, you can't interpret the map. So invariably, what we are saying is that the conventional signs, they hold the key to interpreting the map. Without the conventional sign, the map is locked. You can't open it, you can't interpret it, you can't make any meaningful deductions from that map. All right, let's look at some of them. So look at this. We have their names here, we have the signs here. When you see this sign, it means trigonometry station. Now that trigonometry station is a primary trigonometrical station. When you see the triangle with the arrow, with the head of the triangle pointing up. But when you see the reverse, when you see the rectangle with a dot inside, with the head of that rectangle pointing down, is another trigonometrical station, but it's a secondary trigonometrical station. Then let's look at the third one, is the spot height. Spot height is like an elevated height in the map. They represent one of the highest altitude in a map. Then built up area, you will see a cluster of settlement or houses, as it may be, in a very clustered position in the map. When you see such, it means it's a built up area. It's probably a town or a city or something of that nature. Then main road, you see main road like a very straight line in the map, a very straight line that is very thick. That's usually main road. Then minor road, you see minor road with a dark color in between the main road. The railway line, you see a line that is crossed, that is railway line. The airport, you see something that looks like an aeroplane in that map. That means that place is an airport. Then hospital or dispensary, where people get drugs and medicine and get treatment. So you see either a cross or hospital with a dot or a DISP, hosp or DISP. That is for hospital. Then for school, you have a dot and SCH. That is a school. If you see that sign, it means that there is a school here, an environment that is good for learning. Then the next one is court. Usually you see dot and CT. That CT represent court, and that means it's a judiciary. It's a judiciary building or a judiciary settlement or place or an administrative settlement. So you have rest house. If you see rest house in the, or maybe a guest house or hotel or whatever, how do you know that? You will see dot and RH. That RH represents rest house. Then we move on to market. you will see dot and MKT. MKT, dot MKT. That is market. Then oil palm, you see this sign that look like a palm tree. That's an oil palm plantation. Then you see for a heavy forest, you see something like this, and etc. For a light forest, you see this. For shrub, you see this. Then for mangrove, it's slightly different from shrub and grasses. For mangrove, it's upside down. Then for plantation agriculture, you will see something like this. When you see this kind of sign, it means there is a plantation agriculture. Most likely, that environment is a rural area. That's how to interpret conventional sign. Then for a lake, you have a something that looks like a dam on a river. Then for area liable to flood, you will see dash. All this dash line, they will be clustered around a particular area. How will you identify that this place is an area liable to flood? Is when you see a river going. When you see a sign of river, rivers are often represented with a blue line in a map. Blue line in a map. So when you see all these dash sign, and especially when it's a blue line, it means it's an area that is liable to flood. Then contour. Contour is very easy to identify. You see a line and you see a number on it. That is a contour. Then mining site. For a mining site, you can see something like a spade and hammer crossed together. That is a mining site. Alright. So, having said that, I want to appreciate you for participation. I want to thank you for tuning in and being part of the lecture today. I want to sincerely wish you good luck in your exams. I want to wish you good luck in your academic journey, even as you learned in this class that map reduction is basically needed when you want to reduce a map so that it can contain the needed information per se, not many information. And map enlargement is needed if you want to add many information that as much as needed in the map. So thank you very much for being part of the class today. See you in my next video. Goodbye.